All right, welcome, and now we're going to do another example. Before we do the example, it's important to know that in the definition, we define that, that we're talking about a basis, which again is a sequence of vectors, right? So we do that because so we can have an order when we write the representation. There's an order to the coefficients. Also, keep in mind that if there's only one basis, we usually omit the subscript if there's only one basis that we're dealing with. Okay, so just keep that in mind. Okay, so let's look at this example. It says in R2, to find the coordinates of the vector space, of the vector V, to find the coordinates of the vector V, right, okay. So to find the coordinates of the vector V with respect to the basis B given here. Okay, so we want to find the coordinates in the representation, right? So in order to do that, as you might think, and it should be kind of clear to you at this point, that we're going to take a linear combination of these two that should add up to equaling the vector, right? So let's do that. So we're going to do C1 times 1, 1 plus C2 times 0, 2, and that should equal 3, 2, right? And so again, this is going to give us our system, right? Our system is going to be C1 equals 3 and C1 plus 2C2 equals 2. And right away we can see how this is going to be solved. Okay, so we know C is equal to 3, so then that means C2 has to equal what? It has to be equal to 2 minus 3 quantity divided by 2, which gives us negative 1/2. And so we found our coefficients. Okay? Now, writing the representation as a column generalizes the familiar case in R sub n, and with respect to the standard basis of epsilon sub n. Okay, we'll talk about that in the next video, but now we can write this representation, rep, and again, we're just dealing with B, but I'll put the subscript just for clarity. So, if I can write well, the representation of what? V, with respect to the basis B is equal to 3 negative 1/2. And that's it. Have a great day.